Hello everyone. Today we are going to learn about operations on process. Which are the operations we can perform on process which is present inside the main memory. So there are four operations which can be performed on a process. First is process creation, then you can perform process termination operation, then process blocking operation and process preemption operation. So these are the main four operations which you can perform on process which is executing inside the operating system. Now first operation which is performed is process creation. So here system initialization or system booting. This means you are putting on the system. Suppose your system is off, you can put on the system. So that is called as system initialization or system booting. So when you put on your system, it creates the background processes like email, logon gets created. Then user requests to create a new process. Suppose I want to open the Word. So this Word will become my new process. So now I am requesting OS to create a new process, that is Word. Then already running processes or existing processes can create a new process. Now example, suppose this Word is already open on my system. Now it is a running process. I can create from the Word the new blank document. Okay, so now I have two Word documents open. So first one was initially I opened this and I typed one line. Okay, and from this already open or running process, I have created the new process, which is this process. Okay. So already running or existing process can create a new process. Then batch system takes initiation of batch job. Now second operation that can be performed on the process is process termination. Okay, when you can create the process, you should know how process is terminated also. That is how process is closed or shut down. So first topic under process termination is process triggered. How process is triggered. So when process completes its execution, it executes exit system call to indicate to OS that it has finished. For example, now this program is open inside my code block editor and I want to run this. So when I try to run this program, it will go inside the main memory and it will become a process. When the CPU is finished executing this program, this process will give indication to the operating system of my computer, indicating that it has finished its execution. So exit system call will be given to the operating system by this process. So once the exit system call is given to the OS will terminate the process. Okay, and this way your process gets terminated. Now next under process termination is OS triggered. Now there are service errors like no memory left for allocation and IO errors. Okay, so service errors will be given by operating system. And another one is preemption of a process when total time limit exceeded. OS will terminate the process if there are service errors or there is preemption related error. That is preemption of the process when time limit is exceeded. You cannot preempt from one process to another process execution. So OS will try to terminate the process. And if there is no memory left for allocation and for IO errors, then service error will be given by OS, that is your operating system, and operating system will try to terminate the process. So in both the above cases, process will be terminated by your operating system and they are called as total errors. Now third case of process termination is hardware interrupt. If it occurs, then your process will be terminated. Like arithmetic errors, out of bound memory access, etc. are program bugs which terminates a running process. If there are any arithmetic errors are there, calculation errors, if you are trying to divide by 0, suppose you have written the program, okay, to divide two numbers. You have taken two numbers, int a and suppose int b, and a is suppose 5 and b is 0, and this is the answer variable for storing the answer, and you are trying to divide a by b. So a is 5 and b is 0, so divide by 0 means it will give infinity as the answer. Okay, so your program will go into the infinite loop. Okay, and in arithmetic errors if occurring, then in this type of cases program bugs will be given and your running process will be terminated. So in case of arithmetic error and out of bound memory access, program bugs which will terminate a running process. So now this program will be terminated because of it will be considered as a hardware interrupt triggered and process will be terminated. Then another case of process termination is software interrupt. Now process can be terminated by another process by executing system call to kill the process that inform OS. Now process 1 and process 2 are executed simultaneously, suppose, and this is a OS. One part of the memory is always taken by the OS. Okay, so process 1 can terminate the process 2, which is executing simultaneously. How? It will terminate by executing a system call to kill the process that it inform OS. So process 2 will inform OS by executing a system call to kill the process 1. So in this way, process 2 is terminating process 1 because it is telling OS to kill the process 1. How it is telling? By sending the system call to OS. So process 2 will send a system call to OS to kill process 1. Okay. So these are the 4 cases of process termination. First is process triggered. Second is OS triggered. Third is hardware interrupt triggered. And fourth is software interrupt triggered. Now third is process blocking, which is one of the operation performed on the process. So when process invokes an IO system call that blocks the process, and OS puts this process in block mode and dispatches another process to CPU. So this is called as process blocking, means one process is blocked. For example, so now here in the memory there is a process 1, process 2 which are there, and there is a operating system. One part of the main memory is always occupied by operating system. So these processes came in the main memory from the hard disk. In the hard disk, when they were there, they were called as programs or jobs. And from the hard disk, it is given to the memory, they are called as processes. So now process 1, process 2 is there in the memory and they are waiting for their turn to execute. So who will execute them? CPU. Okay. And OS will try to give these processes to the CPU. That is called as dispatching. Now when process invokes an IO system call, input output system call that blocks the process. Okay, if suppose process 2 gets IO system call, it needs the input output. Suppose this process 2 needs the printer. For example, I want to print this Word document. So for printing this Word document, I need a printer. So I'm making the IO system call. Okay. When I click on the print, I am making the IO system call. That is, I want the input output system. That is a printer I want. Printer is a output device. So when I make the system call for this output device, what will happen? Suppose this process 2 is a Word. Okay. So it is invoking the IO system call, that is printing command it is giving. Okay, my Word file is giving the printing command. So that blocks the process. So process 2 will be blocked and OS puts this process in the block mode. Till what? Till my printer becomes ready for printing the Word document. Okay, till it gets connected to printer and printer starts printing. Till that it will keep this process 2 in the block mode. And by that time it can dispatch other process to CPU. That is process 1, it can give it to CPU. Okay, so till the time printer becomes ready for printing this process 2, process 1 OS will take and will give it to the CPU. Okay, so it will dispatch the process 1 to CPU for execution. So this is called as process blocking. So which process is blocked over here? Process 2. Why? Because of input output system call. Now the fourth operation and the last operation you can perform on the process is process preemption. When timeout occurs, process receives a timer interrupt and relinquishes the control back to OS dispatcher. So OS puts the current process in ready mode and dispatches the another process to CPU. Suppose initially this process 1 was given by OS to CPU for execution, but timeout occurs of that process. So when the execution timeout of that process occurs, what OS will do? Timer interrupt will be sent. Okay, and once the timer interrupt is sent, OS will try to give the process 2 to CPU and process 1 will be put up in the ready mode. CPU will execute the process 2 by that time because timeout of process 1 has occurred. So process 1 will be put up in the ready mode by OS and process 2 will be dispatched to the CPU for execution. So this is called as process preemption, operation of process. So in today's lecture we saw 4 operations which are performed on the process, that is process creation, process termination, process blocking and process preemption. So this was all about operations on processes under operating system. Thank you.